Hi, I'm Nick and I'm the CTO of PowerCurve, and in this video I'm going to talk about Vortex generators and how you can use them to increase the energy output of your wind turbine. This is an example of a PowerCurve Vortex generator panel. It has a rectangular base, and then on that base there are some triangular fins where the low side is what we call the leading edge and the high side is the trailing edge. And these Vortex generator panels come in different shapes and sizes, but they all share these common features. So what does a vortex generator actually do? Well, it's there to increase wind turbine performance, and it does this by increasing the energy in the boundary layer and using that to prevent flow separation. So if we think about a vortex generator, it has two fins, and these fins are aligned at angles to the flow. And what this does is as the flow passes over the fin, we have a high pressure side and we have a low pressure side. And this means that a vortex is shed from the fin. Now this vortex has a low pressure core, and that allows it to draw down or entrain higher energy fluid from outside the boundary layer towards the aerofoil surface. And it's this high energy flow that's being brought down that re-energizes the boundary layer. And ideally we entrain enough high energy flow that we re-energize the boundary layer and it remains attached for the entire chord length. And if we can achieve that, then we maximize the lift production, we recover what's been lost, and we reduce the drag. Now, there are two ways that we can use vortex generators on wind turbines. The first is on the outboard part of the blade towards the tip, and that's where we're trying to recover the energy lost due to leading edge contamination and erosion. The second area we can apply them is the inboard area of the blade, so towards the root. And this is where we have very thick aerofoils that lose performance as they're experiencing a lot of stall. So let's look at those in detail. So first let's talk about the outboard part of the blade and leading edge contamination and erosion. So in an ideal world, the flow would pass over the surface of the aerofoil and it would remain fully attached for the entire chord length. And this is shown by the blue flow lines on the video. And when that happens, we get the maximum lift, and that's the green arrow. The problems start to arise when we look at the leading edge of the aerofoil and we see contamination from bugs or dirt, or it's being eroded by impact with raindrops. Now in those situations, we start to get a flow separation where the boundary layer is lifting off the surface, and this is shown by the red arrows. And in those cases, we're actually getting a reduced amount of lift and increased drag, and this is harming the performance of the wind turbine. We're getting less power. So at PowerCurve, we very carefully optimize vortex generator panels, and if we apply those to the blade, when we have the erosion and contamination now, the flow passes over the PowerCurve vortex generator panels, it's re-energized, and we're actually going to recover that lift that we were losing before. So we have the green flow and the enhanced lift. The second area where vortex generators can help us is in the root region. Now, towards the tip of the blade we have very thin aerofoils, and as we move towards the roots, those aerofoils get much thicker for structural purposes. The problem is that these thick aerofoils have very steep curvatures, and these steep curvatures mean steep pressure gradients, and that means we start to get quite a lot of flow separation or stall in the root region of the blade. So in these situations, again, we can use vortex generators. So the vortex generators are re-energizing the flow, and they're allowing that flow to remain attached for longer around the aerofoil surface. And in the image you can see from a wind tunnel, we have some BGs applied, and we have a flow separation zone on the left and a reattached flow separation on the right. So this is great because it increases lift, it increases power. So PowerCurve uses a variety of tools and methods to design our vortex generator solutions. Firstly, we have a wind tunnel test library, and this was carried out in conjunction with the Danish Technical University. We then use blade element momentum methods, which is an industry standard way of looking at performance of rotors, and we use computational fluid dynamics, or CFD. And together, these three tools, these data inputs, can be used to optimize a vortex generator solution for every turbine we look at. So we don't have a common solution, we look at your individual turbine and we figure out what is best for that particular model. So we've now installed over 700 Vortex generator kits worldwide, and in each of those situations we've achieved between 2 and 4% increases in annual energy production. So come talk to PowerCurve and let's see how much energy we can recover from your wind turbines.